Once upon a time, building an AI required a lot of carefully engineered code. Today, when you use tools like Unity, you can build an AI entity in under 9 minutes. The AI entities you'll build today can be used in any game. Now, I know what most of you are thinking. You'll go down to the comment section, say a bunch of terrible things, and force me to abandon this project. But we can get a lot done in 9 minutes. There's plenty of time to write some state logic, and we'll even use different strategies to detect the player if they get close enough. But most importantly, you'll learn how to use AI agents to navigate a surface and how to spawn them randomly. If you're new here, like and subscribe, and you can reference the code on my Patreon to support this series. Before we get started, let's quickly take a look at what we're building today. It's AI Pokemon that wander around the world, kind of like the wild Pokemon in Legends Arceus. For the Pokemon to chase you, the player must either get close enough or within its field of view. Once the Pokemon starts chasing, it will do so until it touches the player. Whenever the player gets far away, it will start wandering around again. It's very easy to implement, and by the end of this video, you'll have a great starting point for building really any type of AI entities in your games. Let's go ahead and get started. Open up Unity and I'll set a timer for 9 minutes. We have one package to install, AI Navigation. Once installed, we can open up the game object where our terrain or environment is contained. First, we'll add a NavMesh surface component. Then we'll make sure the area is walkable for our AI agents, hit bake and create a blue surface which our Pokemon will walk on. But some of our obstacles are also walkable, so let's remove them by adding a NavMesh modifier component. From there, we can tweak a couple of settings. Enable override area and set the area type to non-walkable. Make sure apply to children is enabled so the children are updated. The last thing we do is click on the NavMesh surface and hit bake again. When you do that, it will update the surface and give you a NavMesh object in your scenes folder. And now that we have the NavMesh set up, we need to architect the NavMesh agent. Here we have a wild Pokemon. If the player is not detected, it will walk around randomly. Otherwise, it will start chasing the player until they can't be detected again. To hold all the common data between these two states, we'll have a base class similar to what we did for the player. First, we need to hold references to the NavMesh agent and animator components inside the Pokemon class. Then we need a state machine to transition between the chase and wander states. I'll leave a link to the video where we built it from scratch, and to create transition between the states, I'm going to copy over two methods from the player controller, which are really just wrapper methods for the state machine's add transition and add generic transition methods. We can then initialize the state machine in start, call its update in update and fixed update in fixed update. Now the question becomes, how do we set a state? In our Pokemon base state, we'll implement the iState interface which was created for our player. It contains 4 methods which can be implemented virtually. Inside the class, we'll hold references for the Pokemon, animator, and all the animation hashes of the Pokemon, which use the animator's string to hash method and a value to control how long it takes to update the animation. Now we're ready to create the Pokemon Wander state, which inherits from the base state. By hitting Command dot, we can move it into its own file instead of waiting for Unity to compile it in the editor. Inside the Wander state class, we want references to the NavMesh agent and a distance to control how far to wander. It wouldn't hurt to pass in these values through a constructor, and remember to call the base state constructor too. When the Pokemon enters this state, we want to change the animation to the move animation and give it a random point to move towards. In update, we can check if the Pokemon has reached this point in real time with the helper method. If it has, then we give it a new random direction to move towards from the starting position and within its radius with the random.inside unit sphere method. Then we check if this target is walkable with the NavMesh's sample position method, passing in the target direction, a NavMesh hit, which is an object containing the data for the sampling, and the wander radius. From there, we want to set the destination using the hit object's position property. We can then check if the target is reached by returning true. If the agent's path is not pending, the distance to the target is less than the distance at which it's supposed to stop, and if a path doesn't exist or if the velocity is 0. Back in the Pokemon class, we can now create a property for the wander radius and create a new object for the wander state in start. To test this, let's just add a transition to this state which is always true. Finally, we can set the state machine to this state and go back to Unity. Now we can drag over a Pokemon into our scene and set its position next to the player. Add a NavMesh agent component to it and tweak the values so that the obstacle avoidance values fit the Pokemon size. From there, we can add the reference to our Pokemon script and set the wander radius to something like 10. Apply the overrides to the prefab and hit play. At this point, the Pokemon should wander around the terrain, avoiding any obstacles and completely ignoring the player. We can do this for all AI entities in our game. Just make sure to remove any physics components like rigid bodies to avoid glitches. Now to make the Pokemon chase the player, we want to create a new chase state script. In our code, hold the reference to the NavMesh agent and to a transform which is going going to be the target the Pokemon is going to chase after. We can then create a constructor to pass in these values. From there, we want to change the animation in enter and in update set the destination to the target's current position. But this will cause the Pokemon to chase the player at all times. To detect them only when they're nearby, we'll create a new player detector class which will handle that logic for us. Inside, we want to hold references for the target's transform, the Pokemon's transform, a timer to handle any cooldown logic, and the strategy on how we want to detect the player. The eye detection strategy is going to be an interface which we will define soon and is going to work as follows. So first we have a Pokemon in the wander state and detects the player if they're within an angle of say 60 degrees and a radius of say 10. If the player is within this range, then the Pokemon will start chasing, and once outside it will go back to the wander state. But what if the player sneaks up from behind? We want the Pokemon to still detect the player within a smaller radius, say 5. Back in our code, we'll pass in all these values through the constructor, initialize all the references, and pass in the parameters to our strategy, which we're calling cone detection strategy, which implements the eye detection strategy interface. We also want to update the timer in update and create a public method to tell the Pokemon if the player has been detected, which will check if the cooldown timer is running or if our strategy has detected the player. Before we move on to the execute method, I also want to create a public method in case we want to update the strategy in the future in runtime. In the strategy interface, we can declare the execute method which returns a bool, and it really just needs a target, a Pokemon, and the timer to handle all the logic. In the concrete strategy, we want to hold all the values from the player detector and create a constructor to pass them in. Now in the execute method, we can bail out early if the cooldown timer is running. Otherwise, we can get a direction towards our target and the angle using the vector3.angle method. We can check if the target is non-detectable if they're not within our cone angle or outside the radius, and if they're outside of our inner circle radius, we return false. If the target manages to pass all these checks, then they've been detected. We start the cooldown timer and return true. From there, we can create all the properties for our detection logic in our Pokemon class, including the player detector, initialize it in start. Also in start, create a new chase state object passing in the detector's target. We only want to transition to the chase state when the player detector has detected the player, and transition back to the wander state if the player is not detected. Make sure to update the detector in update. Optionally, we can also refactor all of this code into a new class called wild Pokemon, because later when we want to create the player's Pokemon, they don't need all this chase and wander logic. What I've done is make this class inherit from Pokemon and moved all the properties for our detection logic here. Then in start, we can call the base class's start method, which at this point just initializes the state machine through a helper method, and the rest of the code is moved into the wild Pokemon class. We can also do the same thing for the update method. Just remember to make all the methods and properties protected if you intend to use them from the inherited class. We can now go to Unity, set values for our detection properties, and hit play to test everything. You should now see the Pokemon chase your player when they're within range. If we run away far enough, the Pokemon will stop chasing and wander around randomly again. If we sneak up on the Pokemon, it will still be able to detect the player and start chasing again. At this point, the main problem is that the Pokemon aren't spawned randomly. The way we'll fix this is by using the spawn system we created in my last video, because the reality is that we are getting short on time. We can now add the wild Pokemon and NavMesh agent components to all the prefabs and enable the Pokemon spawn controller. At this point, if you did everything right, your player should be running for their life, being chased by bloodthirsty creatures. Congratulations, you just created dynamically spawning AI entities for your games with Unity. This system is flexible, scalable, and follows all solid principles. I'm going to go ahead and wrap things there. If this video helped you, please like and subscribe, and in the next video, I'll finally teach you how to battle these wild Pokemon with the power of event buses. If you have any ideas, leave them in the comments down below, and thanks for watching.